Hello everyone. In this lesson, I will solve the ministerial questions of differentiable and tangent problem. Differentiability and tangent problem. Question number 1. If f of x equal negative x power 2, then f prime of negative 2. F prime of negative 2 equal to f of negative 2 plus delta x minus f of negative 2 over delta x equal to, limit delta x approach 0. Limit delta x approach 0 for f of negative 2 plus delta x depending on f of x is negative 2 plus delta x power 2 minus f of negative 2 negative 2 square, it is minus 4. Minus 4, it is plus 4 over delta x. The right choice is D. Question number 2. If f of x equal x power 2, then f prime of x equal to f of x plus delta x, depending on this function, x plus delta x square minus f of x square over delta x. Then the right choice is B. Question number 3. If f of x equal 3x, then f prime of x is f prime of x is limit delta x approach 0. Here we have delta limit, I forget it, delta x approach 0. Limit delta x approach 0 for f of x plus delta x, 3x plus delta x minus f of x, 3x over delta x. Then the right choice is C. Question number 4. If f of x equal 2 over x, then f prime of 2. F prime of 2 equal to limit delta x approach 0, f of x plus delta x, it means f of 2 plus delta x minus f of 2 over delta x equal to limit delta x approach 0, f of 2 plus delta x, depending on the function, is 2 over 2 plus delta x minus f of 2, 2 over 2, 1 over delta x. It is A. Choice A. 2 over 2 plus delta x minus 1 over delta x. Question number 5. If f prime of x equals 3 over x plus delta x minus 3 over x over delta x, then f of x is, if we compare this derivative with f prime of x equal to f of x plus delta x minus f of x over delta x, then the term here is f of x. Then the right choice is D. Question number 6. If f prime of x equal to limit delta x approach 0 for 2 bracket x plus delta x plus 1 minus bracket 2x plus 1 over delta x, then f of x, if we compare with this limit with the rule of the derivative using limit, then f prime of x equal to limit x delta x approach 0 for x plus delta x minus f of x over delta x. Then this term is delta x 2x plus 1. Choice A. Question number 7. f prime of 2 equal to the limit delta x approach 0 for 2 plus delta x cube plus 3 minus 11 over delta x. Then f of x is, this is f of x plus delta x. Substitute every 2 plus delta x with x, then the function is x cube plus 3. Choice A. And if you want to check, substitute x with 2, then 2 cube 8, 8 plus 3, 11 should be this term. Question number 8, limit delta x approach 0 equal to this function. Then f of x is 1 minus 3, replace 1 plus delta x with x, then the function is 1 minus 3x. Choice C. Question number 9, f prime of x equal to this limit, then f of x is this term, but this sign should be negative, and since it is positive, then the function is negative 3 over x. There is no this choice, then the right choice is none. F of x equal to this limit, then f of x is this term, but the sign here should be negative. Since it is positive, then the function is negative 4 over x. The right choice is A. F of prime of x equal to this limit, then f of x, it is this term, but this sign should be negative, then the function is negative 2x power 2. The right choice is D. Question number 12, f of x equal x cubed, then the value of the derivative is, if we use the rules of differentiable, then the derivative of this function is 3x power 2. Choice B. F of x equal 2x power 2 plus x minus 1. Then the value of this limit is the derivative of function at 3. The derivative of this function using the rule of differentiability is 4x plus 1. This is the derivative of this function. The derivative at 3 is 4 times 3 plus 1 equal to 13. Choice C. F of x equal negative 3. Then the derivative of this function is 0, since the derivative of any constant is 0. F of x equal negative 3x plus 2. Then the derivative is the derivative of this function using the rules of differentiability is negative 3. 16, f of x equal absolute value x minus 1. Then the derivative at 1 is, which one of these choices? It is none, since if we want to differentiate this function, we should rewrite x minus 1 as x minus 1 when x greater than or equal 1, and negative x minus 1 when x less than 1. Then we differentiate these two segments, 1, negative 1 when x greater than 1 and when x less than 1. So the right choice is none. Question number 17, f of x equal 4 over square root x. Then the derivative of this function at 1. First we find the derivative of this function, then we find it at 1. Rewrite this function as 4x to the negative half. Differentiate using rules of differentiability. Negative 4 over 2x to the negative 1 equal to, reduce negative 2 over x, then f prime of 1 is negative 2 over 1 equal to negative 2. Question number 18, f of x equal to x power 3 plus x, then the derivative at 1, when x equal 1. The derivative of this function is 6x power 2 plus 1, and if we replace x with 1, then 6 times 1, 6 plus 1, 7. The right choice is 7. Question number 19, f of x equal 2 minus x all power 2, then the derivative at 3. If we differentiate this function, then its derivative is 2. 2 minus x times negative 1 equal to negative 2, 2 minus x. If we replace any x with a 3, then the answer will be negative 2. 2 minus 3 equal to 2 minus 3, negative 1 times negative 2, 2. The right choice is C. Question number 20. Find f prime of x equal to this limit. The answer of this question is the function is 2x power 2. Then f prime of x equal 4x. Choice D. Find f prime of x, this limit equal to this limit. From this limit, we can deduce that f of x equal to negative x power 3, this term here. But since the sign is positive, then the function is negative. If we differentiate this function, the answer is negative 3x power 2. Choice D. Exercises, page number 101 in the book of Ministerial question. Question number 1. The tangent line to the function g of x at the point 3,1 passes through the point 4,2 also. Find g of 3 at the point of tangency. Since 3 is the x coordinate of the point of tangency, then 3,1 belong to the function g, then g of 3 is 1. Choice B. The tangent line to the function f of x at the point 2, negative 1 passes also through the point negative 4. Find f prime of 2. We want to find the derivative of the function at 2. The derivative of the function at 2 equal to the slope of the line at 2, since 2 is the point of tangency. Then we will find the slope of the line, since we have 2 points placed in the line, y2, 4 minus y1 plus 1 over x2, negative 3 minus x1, 2 equal to 4 plus 1, 5 over negative 5 equal to negative 1. Choice B. Question number 5. The tangent line to the function g of x at the point 4, negative 1 also passes through the point 6, 3. Find g prime of 4. Since 4 is the point of tangency, then the derivative of the function at this point equal to the slope of the line. The slope of the line equal to 3 minus 1, 3 plus 1 over 6 minus 4 equal to 4 over 2 equal to 2. Choice B. Question number 6. The tangent line to the function f of x at the point negative 3, 4 passes through the point 1, negative 2. Find f prime of negative 3, f prime of the point at the point of tangency equal to the slope of the line. The slope is equal to 4 minus 2, 4 plus 2 over negative 3 minus 1, 6 over negative 4 equal to negative 3 over 2. Choice B. Question number 8. I skipped 7 because I solved it before. The tangent line to the function h of x at the point -2, 1 also passes through the point 0, 5. Then find h of -2 plus h prime of -2. H of -2 is 1 since -2 is the point of tangency. Then h of -2 equal 1. H prime of -2 equal to the slope of the line. Then I'll find the slope of the line. 5 minus 1 over 0 minus 2 plus 2. 5 minus 1, 4 over 2 equal to 2. Then h prime of -2 equal to 2. Now, h of -2, 1, plus h prime of -2, 2, 1 plus 2, 3. The right choice is C. Question number 9. The tangent to f of x at the point -2, 1 passes through 0, 5. Find limit x approach to -2, f of x minus f of -2 over x plus 2 plus f of -2. This limit is the derivative of the function at -2. The derivative of the function at -2 equal to the derivative of the tangent line at this point. Equal to the slope of the tangent line at this point. The slope is equal to y2 minus y1, 1 or 5 minus 1 over 0 minus 2 plus 2, 4 over 2 equal to 2. F of -2 is 1. It's equal to, since -2, 1 lies in the graph of the function, it is point of tangency, then f of -2 is 1, then 2 plus 1 equal 3. The right choice is C. Question number 10. If g and h are two differentiable functions and f of x equal g of x over h of x, find f prime of 1, knowing that g prime of 1 equal to this limit, and the tangent line to h of x at the point 1, 4 passes through point 3, 6. To find f prime of 1, we must find first f prime of x equal to, apply the rule of division of two functions, h of x times g prime of x minus g of x times h prime of x over h of x squared. Now we want g of x and g prime of x, h of x and h prime of x. From this limit, the function g of x is equal to 2x minus 3. The derivative of this function is 2. The derivative, the value of function at 1 equal to -1. 2 times 1, 2 minus 3, -1. The derivative of this function at 1 equal to 2. We find g of 1 and g prime of 1. Let us find h of x, h of 1. H of 1 equal 4. Since 1, 4 lays on the graph of the function h of x, it is the point of tangency, and h prime of 1 equal to the slope of the line, tangent line to this function at the point of tangency 1, 4. So we find the slope of this function, of this tangent line, passes through these 2 points, 6 minus 4 over 3 minus 1 equal to 2 over 2, 1. Then h prime of 1 is 1. Now, h of x, 4, times g prime of x, 2, minus g of x, g of 1, negative 1, times h prime of 1, 1, over h of x square, h of 1 square, 4 square, equal to 8 plus 1, 9 over 16. Choice B. Exercise page number 103. F prime of c equal to negative 2 over 5. Find f prime of negative c when f is even. When f is even, f prime is odd. And since f prime is odd, f of c equal to negative f of negative c. F of negative c equal to negative f of c equal to 2 over 5. F prime of c equal to negative 4. Find f prime of negative c if f is odd. If f is odd, then f prime is even. And for even function, f of negative c equal to f of c. F prime of negative c equal to f prime of c. So the right choice is A. F prime of c equal negative 4. Find f prime of negative c if f is even. If f is even, then f prime is odd. For odd function, f of negative c equal negative f of c. So the right choice is 4. F prime of c equal 5. Find f of negative c if f is even. F is even, it means f prime is odd. For odd function, f prime of negative c equal negative f prime of c. So the right choice is negative 5. H prime of c equal to. Find h prime of negative c if f is odd, then f prime is even. When f prime is even, that means h prime of negative c equal to h prime of c equal to 2. The right choice is B.